Hi everyone, and welcome to Activity 19. Today we are going to talk about the inverse of our trig functions. So if we connect this back to geometry, if we are looking to find the angle measure in our triangle and we want to solve for that theta value using cosine, we'd have to set this up and say, okay, I'm looking for cosine, so I would use the adjacent and the hypotenuse and set up that ratio that cosine of theta equals A over C. And if I actually was looking then to calculate theta, we would need to use the inverse to help us find what that actual angle measure is. So if we are looking for an angle, that's when we would involve our inverse each time, right? We need to use the inverse. So now if we start connecting this to what we've been talking about with functions and especially with cosine and sine, in order for something to be a function, we would say that a relation to be a function, each input must have only one output. So oftentimes we call this one-to-one in that that's what needs to happen in order for this to work, aka it must pass the vertical line test, right? And occasionally we may need to restrict the domain to make this happen. Strict the domain to make it pass. Now, something to note then, if we want the inverse to be a function, our function would have to pass the horizontal line test. So that's when we use the vertical versus our horizontal line test. Now, if we connect this to actually looking at this graph of cosine, is cosine a function? Well, the answer is yes, right? If we draw in all these vertical lines, it's passing that vertical line test. So we would say cosine is a function. However, if we think about its inverse being a function, if we drew in those horizontal lines, this would not pass, right? It's touching in more than one spot. So we would say that the inverse would not be, because original does not pass our horizontal line test. Now, what we could do, however, is could we limit this so that we could make the inverse pass? Yes. Okay, what we can do is we can limit this. Like, let's say we stopped our graph. It didn't keep repeating. We just stopped it once it got to pi. Then we would, in fact, be able to say this does pass that horizontal line test. So we would limit the domain to just being between 0 and pi and would finally pass. Now, here's the thing. Do we have to limit this to just 0 to pi? Or could we have switched it to be a different spot? Sure. Okay, but when we talk about in math land, the idea of this, we have mathematicians who decided that even though there are other places this is one-to-one, mathematicians chose that we are just going to limit the cosine function to being between 0 and pi as our restricted domain. So officially, we could have had others, but the big thing is that we are restricting our answers to be 0 to pi. And again, if we then think about like actually graphing or looking at this officially and able to find the inputs and outputs for our inverse, we'd invert the x and the y coordinates so that we are able to see that new graph. And the new domain is going to be our old range of cosine. So again, this officially is the range of just cosine of x. And then the new range is that restricted domain from our original cosine of x. So all of our answers that we are going to see as outputs are going to be between 0 and pi, aka quadrants 1 and 2. So that's the important piece of today. Like, this is why our calculator is only giving us answers between 0 and pi, is because of this restricted domain. That's what our calculator will read. Now we can see here, okay, officially, like if I'm trying to find the cosine of 1/2, there's more than one spot on our unit circle that we see that happening. For instance, it's happening at 60 degrees, but it's also happening at 300 degrees. However, if we type this in the calculator, it's only going to tell us that answer for 60 degrees, because quadrants 1 and 2, 0 to pi, are going to be where our answers are coming from. So that's why your calculator is doing what it does. However, we know when it comes to actual solving, so what we are going to see later on in activity 20, that's when we would also include values from 3 and 4 as well, but our calculator is only going to give you the output answers for quadrants 1 or 2, if we're looking for the negatives. Now, this is a good time to note that cosine inverse is not the same thing as the secant, aka the reciprocal. Another name, however, for cosine inverse is the arc cosine. So remember, each time basically what's happening is the inverse is when we're trying to find, work backwards to find the angle. So either in degrees or radians a lot of the time. The reciprocal then is when we have, for instance, like 1 over the cosine value. That's then going to equal the secant, but they otherwise aren't doing the same thing. The inverse is finding that angle, that output. Now we're also going to see restrictions happening for sine and tangent as well. Because again, sine, if we look at the original here, yes, sine is a function. However, the inverse would not be a function because sine does not pass the horizontal line test. And this exact same thing can be said for the tangent graph as well, because tangent is going to pass the vertical line test and be a function. However, it's not going to pass that horizontal line test. So we could say the same thing with tangent, that it's going to be an inverse, but it does not pass the horizontal line test, so its inverse would not be. So again, we could limit these though so that it does. If we limited this sine graph, notice this time if we went 0 to pi, that's not really good enough. That's still not going to pass the horizontal line test. So instead, where they limit the sine graph is they go from negative pi over 2 to pi over 2 would be our limitation so that it does pass the horizontal line test. And then same thing with tangent, they limit from negative pi over 2 to pi over 2 so that it would pass. Because if we then cut out all the rest of this graph, it would in fact pass. So we would say that we would limit the original domain for both of these to being between negative pi over 2 and pi over 2. Or sometimes you might see that expressed with the brackets, if we're looking at interval notation. So this time it's kind of limiting it to, if you want to think about like quadrants 1 or 4. Officially though, I like to call it almost like quadrant -1 because we aren't using, for instance, like 7 pi over 4, we're using negative pi over 4. So that's why sine and tangent are often kind of taught together because they have the same limitations versus cosine that's going to go 0 to pi or 0 to 180. So for each of these, they want us to come up with the value for these. Again, make sure we are looking at these in terms of both degrees and radians and in the correct limited range. So for instance, sine inverse being negative square root of 2 over 2. Well, if you think about your unit circle, the y value is negative square root of 2 over 2 at 315 degrees or 7 pi over 4. Well, again, because sine is using that between negative pi over 2, positive pi over 2, or negative 90, positive 90, we would say that negative 45 degrees or negative pi over 4 would be our correct answer there. And again, we can double check this fact if we check out the inverse of negative square root of 2 over 2. We see that negative 45 degrees or negative pi over 4 radians. Cosine is going to be negative square root of 3 over 2 at negative 30 degrees or negative pi over 6. And again, if we check this out in the calculator, negative square root of 3 over 2, that inverse, for cosine, excuse me, not sine, is at 150. Because again, we need a quadrant 2 or 4. So sorry, 5 pi over 6. Because again, cosine, my bad, is in quadrants 1 or 2 if it's negative here. So 150 degrees or 5 pi over 6 on that one. Sine is back to, again, being either quadrants 1 or 4. In this case, it's going to be from quadrant 1 since this is a positive value. So 30 degrees or pi over 6 radians would end up being our answer there. And again, we can take sine inverse of 1/2. And again, we can double check then that we get that. So that's the nice thing about having our calculators to kind of double check on these facts. Tan inverse, tan is going to be, again, quadrants 1 or, in this case, 4, since it is negative. That's at negative 45 degrees or negative pi over 4. Again, we can always double check. Tan inverse of negative 1. And then cosine of negative 1 is going to happen over at negative 180 degrees or negative pi is another way to think about that. Because we have an x value, so positive 180 degrees or positive pi. We have that there. And then tangent, our last one here, is going to be square root of 3 over at 60 degrees or pi over 6. Sorry, not pi over 6, pi over 3. Convert. All right, now sometimes you're going to see more than one of these happening. Each time you want to make sure when you do the compositions, you work from the inside out. And you want to make sure that the correct range is being used for that inverse. So again, making sure that your final answers are located in the right spot. In general, they tend to cancel each other out. So for instance, like 60 degrees, cosine inverse of 60 degrees would work out, and they just kind of cancel out. This is, however, you have to be careful that this is going to happen in the restricted domains only. Okay, what do I mean by that? Well, let's say that we tried to do cosine inverse of cosine of 300 degrees. Okay, 300 isn't officially in our domain, so when we actually take these answers, it's not going to cancel out. It would actually give us that answer of from quadrant 2, since 300 isn't in that correct domain. So you would actually just get an answer of positive 60, because again, it has to be in that correct domain. So for each of these, we are looking for the composition answer. Again, we always start with the inside. So remember, another way of saying arcsine is sine inverse, and then it wants the cosine of 3 pi over 2, or sorry, 3 pi over 4, which is negative square root of 2 over 2. And then if we check out sine inverse of that, that's going to end up being negative 45 degrees or negative pi over 4 radians. The next one, we are starting with pi over 4. That's sine value is square root of 2 over 2. Inverse on that then is going to actually, again, kind of undo itself, and we end up with pi over 4. And then our last one, we start with the inside here, tan inverse of sine of negative 1/2. Sine of negative 1/2 is happening at negative pi over 6. And then the tangent of negative pi over 6 is square root of 3 over 3. And then it's negative because it's negative in quadrant 4. All right, we'll definitely work more with all 3 types of inverses in class. Thanks everyone for watching.